Hello everyone, welcome to the second video of solution of internal second of data science. In the previous video we have covered the first question, and in this video we are going to cover the solution of question number second. So the second question is to provide algorithm for the following task. The first task is data pre-processing. So the algorithms is text cleaning and normalization, where the process is involving tokenization, stop word removal, stemming or lemmatization, and entity recognition. The input for this will be a raw textual data, which can be unstructured data, and the output will be pre-processed clean data, ready for feature extraction. So the algorithm is taking the input as raw data, then we have to lowercase all text in, then we have to remove special characters, numbers and punctuations. After that we have to tokenize and give the tokens, or we have to shorten up or remove, then we have to remove stop words, then we have to apply stemming and lemmatization, which is conversion of the words to their original form, and then we have to perform named entity recognition. After performing all these steps, we will get the output as process tokens and extracted entities. The second task which we have to perform here is classification, and the algorithm for it goes like logistic regression, where logistic regression is a simple and effective method for binary or multi-class text classification, and the steps involved here is input. What input we take for classification is pre-processed text and labels. We have done pre-processing just we have just completed pre-processing, and its output is here taken as input, and the output given is predicted IPC or BNS sections. So input, we have taken data X and target labels Y, and then we have converted text data to numerical data using TF, IDF or word embeddings. Then we have split data into training and testing sets, which goes like X-train and Y-train, X-test and Y-test. And then we are training logistic regression model on X-train and Y-train, where these functions are used with model fit, where we are fitting the logistic regression. And then we have to test the model by using Y-predict, by using dot predict function, and then we are evaluating the metrics using metrics, using performance metrics such as accuracy, precision, recall and F1 score. In the output there will be predicted labels as Y predict. Now we have another method which is clustering, and algorithm for it is k-means clustering. It is used to group similar complaints or topics together. Here input is pre-processed text data and output will be grouped clusters. Algorithm goes like: input is pre-processed text data X, we take it as input, and then we convert this text data into numeric form. Then we initialize k clusters and writes randomly, and then we repeat the same process. We take the mean of them, and then um, rearrange those clusters, and we repeat the same process until the convergence of the mean, and then we assign each data point to the nearest centroid, recompute centroids as the mean points in each cluster, and then we assign cluster labels to data points, where the output will be cluster labels for each data point. Now we have decision tree. In decision tree we have algorithm used as CART, which is classification in regression tree, where classification tree is for categorical data and regression tree is for numeric data. So decision tree algorithm goes like: it involves the steps which is taking input, output and algorithm, where we have taken pre-processed text features and target labels as input, and it will give a decision tree model for classification as output. The algorithm has inputs as features X and target labels Y. We are then splitting the dataset into training and testing sets, which is X-train, Y-train and X-test, Y-test. Then we start with all the data at the root, and for each node we evaluate all possible splits. We evaluate every possible split which is which can be there, and then we uh, split the data. uh, After that we evaluate using Gini impurity or information gain. So in case of Gini impurity, if the one attribute with the lowest or with the least Gini impurity is selected as the attribute, and in case of information gain, the largest value or the highest value is used as attribute, which is information gain is calculated using entropy. And then we are repeating the step 3 for each node recursively until leaf node arrives, and not even a single class have a non-leaf node and it meet a stopping condition. Then we use the train tree to classify new data points. Thus we get the output as decision tree model and predictions y underscore predict prid. Now we have fifth technique, which is association rule mining. Okay, so it uses the algorithm as a priori algorithm which identifies frequent patterns. Like, what actually is association rule mining? If antecedent then condescendant then consequent, if antecedent then consequent, like if this is gonna happen then this gonna happen, one thing is dependent on the other, like there's probability if one thing is happening other thing will also occur. So here we take the input of data set of transactions and we get output as rules indicating strong associations between items. So the algorithm goes like, it has input it has input of transaction data set D. It has minimum support threshold as min sub, minimum confidence threshold min conf. So we have three things: a data set as D, minimum support threshold as min sub, and minimum confidence threshold as min conf. So we have to identify frequent item sets as the first step. We have to generate candidate item sets of length 1. Then we have to filter those item sets to meet the minimum support. And then we have to repeat for larger item sets until no more frequent item sets can be found. Like first first for length 1, then for length 2, then for length 3, then for length 4, and so on until no more frequent item sets can be found. Then we have to generate association rules from frequent item sets. Then for each frequent item set, we have to generate all non-empty subsets S. For each subset S, we have to compute the confidence, where confidence can be computed using I minus S equals to support of I divided by support of S. And then we have to retain the rules that meet the minimum confidence. If the minimum confidence value is after using this formula, after using computing the confidence for each subset, then we are retaining the rules. So in the output we get association rules. This is it for today's video. We'll cover the last question of this test in next video. Thank you for watching.